So, talking about the application or product security, right? So, there are actually five key drivers which actually defines and enables the robust security level of the application or a product from any information system solution standpoint. Okay, so the first driver is the SD3 or the 3R attributes. Okay, uh, so let's look into it. What actually is these uh, driver is actually, right? So see, whenever you are working on any product or an application or any solution, right? Or developing a solution or implementing or testing it, right? Or deploying it, all these individuals are actually uh, is what is the CSSLP is targeted for. So talking about the SD3 and 3R attributes, right? So let me cover them individually one by one. Okay. So when I say SD3, right, it is all about like in order to solve any business problem, the application or the product must factor in the process or in the framework for these aspect of SD3. What does it stand for? The first SD stands for secure by design, and the second one stands for secure by default, and the third one is all about secure by deployment. Okay, so what is secure by design? In simple terms, it is all about ensuring to integrate security requirements or security aspects in across all the phases of the product design. In other words, by virtue of design itself, the product or the application is actually secure. Okay, so that is what secure by design means. And moving on to secure by default, right? So in simple terms, when we say secure by default, it is all about ensuring that the application or the product which is designed to behave, okay, in a secure manner with a even with a default settings or configurations. Okay, so in other words, by virtue of the operation of the product or application is actually it is actually secure. A simple example, right? Say for example, we all been using these fintech apps or mobile banking apps, right? So these applications, right, it is actually secure by design because it always has these authentication interfaces where you have to provide your login interface or a pin or a code or something like that. And by default, these applications are actually configured and set in such a way that it works in a secure manner, right? So unless you do not provision any pin or you do not provision your identification or authentication uh, aspects, it wouldn't actually work, right? So that is what secure by design and secure by default is all about, right? From an application security standpoint. And the third one, to the third SD, is all about secure by deployment, right? In simple terms, we need to ensure that the application or product is secure from the deployment for deployment to the production or to the end user to the usage. In other words, it is secure by virtue of accreditation by the management. So what is accreditation by the management mean here, right? So it is all about the software acceptance where the software is actually been kind of completely the requirements has been captured and it has been architectured and designed and implemented and tested for all the functionality, and it is working as it is expected to be. So once it is working as it is expected to be, that's where the management would go ahead and accredit for the software or the application to be deployed. So secure by deployment is the third SD, which is the part of which is very important from an application or product security standpoint, right? So, well, we covered the first part of what is SD3, right? And if you look into the another part of here, right, we have something called as 3R attributes, right? So what it is it actually, right? So in order for any application or the product, right, to attain these SD3 level, which is secure by design, secure by default, and secure by deployment, right? Uh, so there must be a certain level of assurance the software must achieve, right? So if the software or the application is does not have a certain level of assurance, then it does it does not meet these criteria of SD3, right? So the 3R, which actually goes hand in hand with SD3, is the reliability of the software, the resiliency of the software, and recoverability. So when I say reliability, reliability is all about uh, the software, the way the software or the application functions as it is expected to be, right? So it is all about the functionality of the software or application. When it comes to resiliency, right, the second R, it is all about the strength of the software. So when I say strength of the software, right, so it is all about like what is the capability of the software so that it can withstand any kind of cyber attacks or any kind of unintentional errors or whatever it is, right? So whenever you develop some software or an application, there could be two kinds of uh, issues, or the trust could be uh, broken either through by from an attacker who is actually doing an intentional attack, or it could be an unintentional one, and there could be some human errors, or the other environmental factors might impact the way the software is working or the system is working. Even in that case, if the product or application has been designed in such a way that it is resilient enough, then it would be able to withstand and then ensure that the product is secure, right? And the last one is all about the recoverability. It is all about the ability of the software where it can actually restore itself to an operational state uh, after there is probably an event or an attack, or there is some accidental human error, right? So all these factors could actually contribute to the downtime of the software or the application. In spite of these downtime, if the software or the application can actually kind of restore back by itself based on the design and the way it has been architected, so that is where the recoverability aspect is actually being designed into the product. Okay. Okay, so that's about the first key driver for an developing or a secure software, which is all about secure software development, right? As part of the CSSLP. And the second one that is most important is uh, the policies and standards, right? So from an application security standpoint, uh, for these for any application or the software to be secure, right, the the organization or the company, right, must define policies which would actually drive the secure development lifecycle processes and as part of the project development methodologies. And also, we must adhere to the standards. Well, when we say standards, um, the adherence to the standards would be as per the application or the product which is in consideration. Okay. So what I mean by these sentence, I'll be covering now. So before I cover more on standards, let's understand what is policies, right? So a policy is actually an instrument which can actually provide the required enforceability, uh, which is actually required whenever you want to kind of integrate security into the software development lifecycle, right? So policy kind of acts as an instrument where it can enforce such kind of requirements. Of course, it has to be driven by the top management with the support from the top management or the senior management in any organization. Okay. On the other side, standards kind of support policies as well, because when you want to adopt a certain policy, standards also go hand in hand with policies. And standards are actually a kind of a mandatory element of any security program in the organization. Okay. So, in fact, there are wide number of standards in place, which actually clearly specifies, dictates, and captures the details and the level of security that shall be attained by the software or the application. Okay. So, in a broad manner, there are two types of standards. One is internal standards, and the second one is the external one. When you talk about internal standards, it is all about the coding guidelines that the organization would have defined, or there are certain coding guidelines which is also kind of been standardized by at some certain industries. And then when you adopt those standards, you ensure that the software has been designed in a modular fashion and also in a secure fashion. Okay. And when it comes to external um, standards, we have different types, whether it could be industry driven. When I say industry driven standards, we are talking about something like for a credit card industry, we have something called PCI DSS, Payment Card Industry Data Security Standard, and HIPAA, the Health Information Portability and Accountability Act, which is for the healthcare. So these are industry driven. Okay. And we do have some government driven standards like at the uh, specifically in US, we have something like NIST, and at the across the global geographies and at the international arena, right? We do have standards like ISO, and sometimes we do have national level standards like FIPS, the Federal Information Processing System Standards, which is used predominantly as part of cryptography. Okay, we'll be talking about cryptography aspects in the another topic. So, in a nutshell, right? So the policies and standards kind of directly influence the secure development of a product or an application, right? Okay. And the third driver for the secure software program is the people, process, and technology, right? Well, these three key tenets, right? The people, the process, and technology, right? They actually play an instrumental role for any security program, be it in information security or product security, application security. You pick any security program, these are the three key tenets: the people, process, and technology. And when it comes to having a kind of and developing a secure software, right? So again, these tenets also play a key role. So from talking about people, right? It kind of comprises of the top management, the architects, the developers, testers, the operational teams, and multiple individuals and stakeholders within the organization who are kind of either responsible for governance of software or the product, the compliance aspects, the legal aspects, and also on the developing the software as such as well, architecting, designing, right? So all these are like we have multiple people or the individuals who are part of organization, and they would play a key role in terms of coming up with these secure software for an application or a product. For instance, when we talk about top management, they are responsible for defining the policies. Architects are responsible for designing and architecting a software or an application in line with the industry standards that the product or the application is being developed. And developers are responsible for aligning with the coding standards and aligning with the industry standards as well, which the architects have actually kind of provisioned the input. And for a testers or validation team, they need to kind of align with the verification and validation standards. Okay. And on the operational team would actually need to align with the certification and the accreditation standards and the procedures or the frameworks that have been established, right? So there's a lot of people being involved, right, in this entire process of secure software development, right? And speaking about the process aspect of a software program for a more robust application security, right? So for sure, it starts with the software development lifecycle methodologies the company actually kind of adopts, be it like a waterfall uh, software development lifecycle or an agile development lifecycle, right? For sure, these methodologies comprises of the phases like requirement phase, design, implementation, test, and then acceptance phase, right? So these are different processes which actually plays a key role for developing a secure software. And along with the methodologies, we need to also define the protection needs as well. Like what I mean by protection needs is like when we develop a software for an application or for a product, right? Um, we need to understand what are all those aspects that I need to protect. So going back to the similar example of the mobile banking application, right? What does it need to protect? It needs to protect your banking information. Like it needs to protect your login information, like your username and password, which is all about confidentiality aspects. And it needs to protect any unauthorized changes or modifications. For example, if you're initiating a transaction and then if you're initiating a transaction for a 1K, it should be just 1K. It should not be like 1.5K or 10K, right? So nobody should be able to alter or modify that. And whenever you want to use this application, you want this application to be available at your service as you need it, as you are looking for the service from the banking side. So that is the availability concept, right? So if you look into it, right, so we are talking about now touching upon the core security concepts of CI and A: confidentiality, integrity, and availability. So this is what I need to actually protect from an application development or a software standpoint. So in order to protect that, I would have a process in terms of what are the protection needs I need to uh, have in my system, and how do I do it. I would undergo through the process of something like an attack surface evaluation, which means that I would be evaluating what are all the different possible and probable attacks the application can be subjected to. So in the same example, If your username, if the password is compromised, somebody can actually impersonate you, right? And if the transaction has been compromised, somebody can alter the transaction, or somebody can actually attack the banking servers itself and make them unavailable, right? So these are the all plausible attack surfaces, and then we, as a process, we need to evaluate them and ensure them that the software has been designed in a secure manner, right? So other processes which is also part of the secure software development lifecycle is like the incident management. If at all there is an incident, how do we handle it? And then problem management, or if there's a problem in terms of once you have an incident, once you kind of do the deep dive into it on the incident and then analyze, and then you figure out what is the problem. And then once you figure out what is the problem, you need to manage it for sure, right? Because if you do not manage the problem, and then the incident is going to happen again, and then it is going to impact the business, right? So the problem has to be managed, and once we have identified what is the problem, we need to apply some changes around it within the software or within the application or for the product, whatever it is. So we need to go through these change management processes, which could also involve a couple of processes like the patch management and the vulnerability management. Okay. And some of the other processes when we are developing an application or a software is like we would also go through sometimes the software acquisition processes as well, where the software would be acquired from an third party or from an vendor, and then we would integrate into our systems. So there would be a process around it, so that we need to ensure that it is secure in nature, and also there is a supply chain involvement as well as a process part, which also must ensure that there is a secure way of procuring the software through the supply chain process. And speaking about the last tenet of the uh, information security, the technology aspect, right? It the technology aspect is something which is actually very critical, right, from a secure software development perspective. So it kind of comprises of all the controls that we can actually select and apply to our product or to our application, so that the foundational security concepts of confidentiality, integrity, and availability. Alongside with that, we do have the some of the action-based security concepts like authentication, authorization, and accounting or auditability, right? So these concepts, if we were to kind of attain in our product, right? So the technology aspects is the one which is actually is going to kind of enable it, right? So some of the technological aspects which gets actually integrated into the product or an application to meet the security requirements are like the cryptography and access controls, identity and access management, backup and restore, and to name another few and couple of them, it could be like digital certificates and digital signatures and so on, right? So if you look into it, right, like and look into this people, process, and technology aspect, right? So this is actually a kind of an key enabler when we talk about in incorporating the security practices uh, into the software development life cycle, so that uh, we kind of ensures ensure that uh, within the all the disciplines in the field of information security, we have kind of factored in the relevant methodologies and frameworks, right? And the fourth driver, I would say, is like it's the secure design patterns. talking about the patterns here, right? From a secure software standpoint, what are patterns, right? Well, patterns are actually, in simple terms, they are actually the principles and concepts which we kind of uh, inculcate or integrate while we are actually kind of designing and architecting the software. Okay. In a security world, right? In a secure software development world, the most common patterns are like least privilege, where I ensure that only a certain level of privilege has been provided to the user so that I can maintain the confidentiality aspect, right? And another pattern is separation of duties, so that I ensure that we can ensure that uh, an individual is authorized to carry out only a certain task and not any additional tasks, so that we kind of segregate the tasks that needs to be carried out, so that we clearly authorize individuals to carry out the task that is assigned to them one day. So that's where we kind of separate the duties, right? And other patterns are like defense in depth, right? Like so, well, when you develop any product, or like when you integrate enable security for any system or product, right, or application, you cannot just rely on one layer of security, right? So you'll have multiple layers of security integrated, so that if there is a compromise in one layer of security, you kind of rely on another layer of security in the system, right? So that is where defense in depth kind of patterns enables a robust security posture for a product. Apart from these, we have other patterns like the resiliency, which we covered as one of the R in the first driver, right? So the ability of the software to kind of withstand the any attacks, and then also kind of fail in a secure manner. So fail secure is very important. And we do have something like the open design, right? Because the open design is all about utilizing the proven components in the secure software development. A classic example is if you want to use a cryptography, you need not kind of reinvent the wheel and then come up with some cryptographic algorithm. You could rely on the proven algorithms, which is out there and in the uh, security, right? And uh, well, and another most important pattern is the psychological acceptability. See, usability versus security, there is always a kind of a tug of war, I would say, right? So, if you want to provide a seamless user experience to the user, to the end user of the application or the software, you could kind of, it could result in a situation where you could probably compromise the usability or the security aspect. So, how do you kind of design your application or software in ensuring that you, on one side, you provide the seamless user experience, but you also still make it more secure, is right? So that is where the pattern of psychological acceptability plays a key role, and then you need to factor in these patterns, right? So there are multiple patterns like these in the software development or in the application software, and depending on the business needs, we might need to kind of select one or more of these patterns and apply them uh, in uh, in tandem or in conjunction with the software security, uh, so that we kind of arrive at a robust software solution. One important thing to remember with respect to design patterns is that like none of these patterns or concepts cannot be ignored, because all these patterns or concepts kind of influence in arriving in at a secure software or a solution for sure. Okay. And the last driver is all about the like, well, after going through these all these drivers, right? What is the end goal, right? So in combination with all these drivers, right, the end goal is to attain the software assurance and quality, right? So the quality of the software can be attained only when any flaws in the design or bugs in the implementation has been kind of handled uh, in a focused manner, right? So that is where, as a CSSLP, the individual has to have a kind of a laser focus on these phases, especially on the design and implementation phase, where you look for the flaws and bugs and ensure that none of these flaws and bugs actually kind of exist in the product once it reaches to a stage where it is ready for release or a deployment, right? So how do we achieve the quality or the assurance, right? The QA. The QA of a software can be achieved by testing the software or the application for its reliability, recoverability, resiliency, and along with also with the interoperability and privacy aspects, right? Because uh, the interoperability and privacy or other aspects, which is also kind of plays a key role in coming up with a secure software and when it is actually interfaced with other system elements or system components, right? So the software which you kind of going to develop or deploy is not going to operate in a standalone or a siloed manner. It is going to be integrated with multitude of systems and interfaces, and these software must be able to be kind of be designed in such a way that it is interoperable, and then also it kind of maintains the privacy aspect as well, right? So once the software is kind of verified and validated, the acceptance process, right? So with what is assurance, right? So assurance is all about the acceptance process, where we kind of certify and accredit the application for the deployment. So yeah, so moving on, all these five drivers, right? The five drivers which we actually kind of covered until now as part of the application or product security can be achieved only if and only the organization adopts SDLC approach. Uh, the SDLC also can stand, though it stands for Software Development Lifecycle. Here, the SDLC is actually kind of focusing on secure software development life cycle. So the S stands for here as a secure as well. Okay, so if you were to kind of align the with the security, right? So it is important to kind of have this approach of left shift. So what is left shift, right, team? So generally in the development life cycle, right, it starts with like as per like the NIST standard. So it starts with the initiation phase, okay, which is the first phase. And when you kind of capture these phases, the different phases of the project, right? So it starts with the initiation phase on the left, and then moves to the development phase, and then to the implementation phase, followed by the operation phase, and finally with the disposal phase. As we move from left to right, so we are then we start with initiation, development, implementation, operation, and disposal, right? So with all these phases in place, whenever we talk about coming up with the secure software or an secure application, right? Uh, the security must be actually kind of built in at the right from the initial phases of the project. Bolting on the security is going to result in humongous cost to the organization, and then sometimes it is really difficult to kind of bolt on the security to some of the applications or product because the way the design and architecture has been carried out might not uh, enable or make way or path to for the bolting the security at the later stage, right? So that is why it is very important to have this approach of left shift left approach, where you will ensure that uh, right from the initiation phase, the security aspects has been considered and it has been factored in. So in a nutshell, we are talking about if you want to secure the product and make the product or the application more robust and secure enough, we need to shift left so that we will be able to secure them in a right manner. Okay. So until now, right? So we have been talking about the different aspects of application of the product security and what are the different aspects that is being uh, covered at a very high level from a CSSLP standpoint, right? So if you were to get uh, into the details and specifics, and then if you want to expand more further and then broaden your knowledge and then kind of understand the entire gamut of these uh, complete drivers and attributes that are actually enabling the application security or the product security, right? You need to kind of understand further into the um, the broader perspective of CSSLP as such. Okay, so that is where CSSLP would actually enable and guide you to understand the different domains that is covered as part of these CSSLP, and it would also enable you to kind of build a secure application or a product. Okay, so from a CSSLP standpoint, right? So the CSSLP certification itself, it kind of covers the broad spectrum of topics, uh, starting from uh, the like it does cover 8 different domains. So it starts from the fundamentals of the software concepts. So the domain one would cover the secure software concepts, where we'll be talking about the concepts of CIA, AAA, IEEE, or the identity authentication authorization accounting aspects, and the some of the common security concepts and design patterns as well. Okay, and in domain two, the CSSLP would focus uh, covering the secure software lifecycle management aspects, where the coverage would be around the different software development methodologies like agile, waterfall, and understanding some of the security metrics and uh, integrating the risk management methods into the software, right? And along with some of the frameworks like building security in maturity model and software assurance maturity models, right? So these are the things, different things that would be covered as part of domain two. And domain three of CSSLP talks about completely on the secure software requirements. So when we talk about requirements for a project, the requirements can come from from various uh, aspects. So it could be functional requirements, which could be like to meet the business requirements, and then non-functional, which could be the operational or security, and the requirements could be from also from regulatory or compliance aspects, privacy aspect, right? So the different all possible requirements that needs to be uh, integrated or defined, I would say that needs to be defined for the application of the product, would be covered under this domain, the secure software requirements domain, where would be dwelling into the understanding the use cases and probable misuse and abuse cases, and then uh, clearly coming up with the specification of the security requirements for the project. And domain 4 would cover the architecture and design aspect, where the architecture would cover the all the different design patterns and ensure that there are no flaws in terms of the way the software or the application has been designed. And it would also cover a lot of technical aspects like the different computing capabilities, uh, depending on the different technologies that has been used in the application, and the interfaces and designs around it, and some of the modeling aspects like threat model and attack surface evaluation would be carried out in this domain, would be covered in the domain of secure software design. And implementation would talk about how to actually kind of implement a software in such a way that it is secure in nature, right? So it talks about the different kind of programming aspects that needs to be considered, like input validations and sanitizations, right, and resource managements and application of different uh, technological aspects like cryptography and so on, right? And then also it talks about like how to kind of use some of the tools, like static application security testing, or dynamic application security testing and so on, so that in a nutshell we ensure that the software has been implemented in a secure manner. And then in domain 6, we will be focusing on how to test this software, specifically from a security standpoint. So it all covers around the secure way of testing the software, uh, through different kinds of tests like penetration tests, simulation tests, fuzzing tests, and so on, right? And once the software has been tested, and now we are in a phase where the software is ready for deployment and operations and maintenance. So domain 7 would cover around these topics in terms of deployment, how to deploy the software in a secure way, which would talk about hardening and resource management and so on, and configurations, baseline configurations, and secure installation aspects, right? And monitoring aspects, and then the processes with respect to the monitoring, and the processes with respect to operation like incident management or event management and so on. And finally, the domain 8 would also touch upon the supply chain aspects of the software, because when you develop a software, you would either rely on software from a third party, or you would rely on software from an open source, or you would rely upon a software which has been kind of outsourced, right? So, depending on the kind of supply chain that you are actually being selected as part of your development, uh, you would have the associated risks that you would need to manage. And then domain 8 would ensure to cover those secure software supply chain aspects in terms of supply chain risk managements and third party software risks, and proving the provenance aspects and so on. So once you are kind of uh, aware of these all these domains, right? So once you kind of have these knowledge under your belt, and then you would be in a position to understand, like, okay, so uh, what are the different activities that needs to be carried out right from the initial phase of the project, and then with the end goal of building a secure application or a product. Okay, and that is how CSSLP is going to help you in kind of attaining or this goal of coming up with a robust application or a software. Excuse me. Okay, so with that, we come to the end of the I would say the webinar today, where we talked about like the different drivers, and then the approach, and also on the certification aspect.